Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello, and welcome to another episode of the Chai Time Data Science Show. In this episode, I'm honored to be interviewing another one of my machine learning heroes for the second time, creator of MuseNet and member of the technical staff at OpenAI, Christine Payne. Christine studied physics at Princeton, neuroscience and medicine at Stanford. She then moved away from science to work as a musician and recently transitioned into deep learning research. Christine has been an amazing inspiration and role model to me, as I'm sure to many others. She has been kind enough to already share her journey on my blog interview series, to which you can find a link in the description of this podcast. In this episode, we talk all about MuseNet, OpenAI, and deep learning research, and online courses, MOOCs for machine learning, deep learning. Enjoy the show. Hi everyone, I am really excited to be interviewing Christine Payne for the second time. So she's already been on my blog interview series. Thanks Christine so much again for joining me.
Yeah, thank you for inviting me. It's fun to be here.
So during our last interview, you had mentioned that you discovered deep learning by chance. You were like trying to build an app that would flip pages by tracking your eyes. So could you tell us like where did the inspiration for Clara, which if I may is the like younger or the baby version of MuseNet, came from during that period?
Sure. It actually came because I was at that point just trying to learn everything about all these different modeling techniques, and I was trying to learn about language modeling at that point. And so I felt like I was kind of like reading how this was done, and I was following along, but I had the sense that like, okay, if I really want to learn it, I have to build something on my own.
Right.
And so I thought, well, like, what do I know about? I know about music. And so I thought, like, maybe I should just figure out how to translate all these different models to music. And then this will be a way of, like, I have to actually build stuff on my own, but also, like, try things that maybe no one's tried before or hasn't tried as much before.
Yep. I think it's still sort of a very fresh field. So, like, could you, like, for the people who don't have much idea about this, like, what's the challenge here? Like, why can't we just go model.fit and, like, generate jazz music?
Let's see. So a couple different things. The thing with music that I find challenging is that it's there's just this huge range of timescales. So like if you look at a waveform, like showing the audio of a piece, there's like really, really fine detail. So we'll hear frequencies, like even though a lot of the musical pitches are relatively low frequencies, a lot of what we think of as like, this is what a piano sounds like, or this is what a singer sounds like. It depends on those super high frequencies as well. Yeah. And we're really sensitive to mistakes in that. So like we really notice if you get like the sound of the piano a little bit off or little details, or if you mess up with the rhythm in a piece, we notice that. So we're very sensitive to little errors. But then we're also sensitive to like, if you generate a piece that's a minute long and it just wanders and makes no sense or changes halfway, like we notice that as well. So there's, I think in some ways that whereas in a photo, like we might be like, if the corner of a photo is a little weird looking, or if like someone's hair in a modeled face is not totally perfect, like we're usually okay with that in a way that if it was the same degree of mistake in music, we'd be like, oh, that's just really weird. So that to me is why it's a hard problem.
I think because it's such a subjective field. So like, and these mistakes do like get broadly like agreeable to everyone that, oh, that did not sound good to me.
It's true. Both of those things. It is very subjective, but then also like, I don't know, like even my kids, they're like, oh, that just sounds bad. Like they tell me all the time when stuff sounds bad. So yeah, like they definitely, like humans are just very good at like our ears are amazing and we're very good at noticing little mistakes. So.
So could you tell us, like, once you got Clara to work, which in itself was like amazing, like I remember you had put up an app where we had to distinguish between like if it came from the model or if
Right.
it's from a real human, and I would lose to it all the time. So once you had that ready, like how did you find the next idea? So like how to improve upon that?
Interesting. So, so basically, at that point was when I started my fellowship at OpenAI, and at that point, I thought I was going to study some other things. But at OpenAI, everyone was very excited about this transformer architecture, and so I was learning about it on the side there, and I realized like, oh, it's actually really good at doing this sort of long-term structure that music really depends on, in a way that before. So Clara was based on an LSTM. And something that I find kind of interesting is that you can actually hear in Clara's patterns that it tends to be a little bit more local. So you'll hear the model, like if it's doing a scale, it'll want to just continue on a scale, or so it sounds very, very coherent in like a local sense. But then if you listen to it for like a half a minute or 45 seconds, you start realizing like, oh, it's just like stuck in these super predictable loops, because it's like there's nothing pushing it to take a risk, knowing like, oh, melodies always go like a thought, and then a longer version of that thought. Whereas with the transformer, it's better at being able to look across a longer distance. And so that was sort of my thought of like, okay, let's see what happens if we try this very different architecture.
And I think like I'm not an expert like you for music, so to me like Clara sounded somewhat like repetitive in a theme. So like that
So
particular.
that's
Sorry, go ahead.
Yeah, no, that's exactly it. So to me, that repetitiveness is guessing, like the safe guess of what to do. So like in music, the safest thing to do is just a vamp, like just keep playing the same thing over and over and over. And you have to kind of be more confident, or you have to have a better sense of long-term structure to think like, okay, I've been doing this too many times, like now is the time that I should move on. So you have to have a better sense of big structure to do that.
So I actually tuned into the complete concert of MuseNet. One thing I want to ask you is that I couldn't, and I remember like you were kind enough to share a piece before like it went live with me. So even then, and even during the concert, I couldn't make the difference. Like even my friends who aren't from tech background couldn't tell if it's from a human or if it's AI generated. So
interesting. Okay.
One question is like, was that cherry picked the concert, or was it like done live?
The concert, like literally the day before, Greg told me like, oh, it'd be really cool if you do a live concert. So I was like, what? Like, so yeah, no, there was no cherry picking. I didn't listen. Like I literally listened to maybe a minute or two just to like make sure I had my setup correct. But like honestly, I like when I logged in to start listening, I was like, this could be a disaster. Like I have no idea what's gonna happen. So like there was no cherry picking. There was no even like if I were gonna do it again, I would probably like at least try to choose prompts that I thought the model would do well on or something like that. But this was like that was totally random.
I mean that speaks to the model also, because like in research people usually cherry pick the best results, or for generative modeling they pick the best images to showcase, or usually like it's sort of misleading in a sense sometimes.
Yeah, no, I agree. And I also like totally understand that instinct, because, and even as, you know, human composers, we do that too, right? Like, or human artists. It's not like human artists just like publish everything they ever create. Like we have tons of like good ideas and tons of bad ideas, and like you don't want to show off everything. So like I think to a certain extent, maybe that's part of creativity, is like generate a bit of everything. But yeah, I did appreciate Greg sort of pushing me to be like, no, just show what the model can do now. Like, don't pretend that it's better than it is. Like, so show that it's good at some things, it's bad at some things, and just kind of just put it out there. So.
Okay. So to the people who don't know what MuseNet is, maybe if you could give a 50-foot view of it, and how does it generate so realistic sounding music?
Sure. So MuseNet is, it draws inspiration from the way language models work right now, which is, so the way you do language modeling is you train a model on this task of guessing what word is going to come next. So humans tend to be pretty good at this. We hear a sentence and often we can like finish what we think the person's going to say next. And the idea is that a language model is good if it can also do this task of guessing what are plausible things to do. And you can imagine the nice thing about that is that as you get good at that task, there might be there's sometimes when there's only like one word that could possibly come next. Like usually you don't want to mess up verbs, you don't want to mess up, certain things you don't want to mess up. But there are lots of times when you could think like, oh, actually there are like 4 or 5 different words that are all could make sense here. So going back to MuseNet, I do pretty much the same exact thing, except instead of training MuseNet on the task of what word is going to come next, I'm doing what note is going to come next. And so there's a little bit of challenge of figuring out, since music's a lot like everything happens at once and then you move forward in time and then a lot of things happen. So there's not quite the obvious like one-to-one translation, but a lot of it is basically how you can get music into this format where a model can learn the same thing like that.
So essentially you've converted music into like text generation problem?
Basically, yeah. So it's very similar to that. The model's not exactly the same as a text generation model in that I do give it some information about the timing. So it knows it's the sort of position embedding has also information about where it is in time, but otherwise it's a very similar kind of model. Yeah.
Okay. And also like music, like in language, you just have a single word going and you next have the probability of like what could come after that. And MuseNet, I think it works on multiple instruments now. So how do you like take care of that? And how do you like transcribe multiple instruments and generate for that?
Yeah. So right now, MuseNet is based on a MIDI format, and MIDI is a sort of simplified way of representing music, where you get all these messages that tell you this instrument turns on at this volume, and then you get a sign that's like now wait for a certain amount of time, and then maybe now that note turns back off, and so there are all these event-based kind of things, and so I sort of used a modified version of that as the tokens. So the same way that, for language, you have the tokenization problem of how are you actually, like, what are you actually going to feed into the model? It was sort of the same thing for music.
Okay. And MuseNet, I think it's based on top of a transformer model. So was this like a collaborative effort for you? Because I think OpenAI has a lot of experts who like created the GPT-2 model and like, did you like work with them and was their expertise helpful? And how did you like experiment that transformers might be the way to go with this?
Yeah, no, absolutely. It's sort of, with I think GPT-2 were really pushing the idea of transformers, being good at this. And then around the same time that I was playing with music, people were also playing with, can you do this on images? What else can transformers be good at doing? So, I left. We had like, oh my gosh, we had so many different versions of the transformer floating around the office, and like eventually it kind of coalesces on like this is actually a good version. But it was kind of hilarious how a lot of people were interested in it and trying out different things. So yes, it was not like I was trying to figure this out totally on my own in any way.
And like, do you think it speaks for the versatility of these transformer models, or is it also about like how you manage to convert music into this problem? So after like processing the MIDI files and all that efforts that went into that.
Yeah, no, I think it's a little bit of both. I think like the reason we're interested in it as a research group is that we're looking for algorithms that are actually very general. So, the ideal, right, would be to have either a neural net or some sort of architecture that's able to learn about music, but also able to learn about video, is able to learn, like we as humans can learn all these different things, right? So, so the end goal really is to find algorithms that are very broadly applicable. So there's certainly like a big part of that. I do think that like where things are right now, there was a lot of, I've tried variations of how you tokenize the music, and it tends to be sensitive to that. Certainly gathering a huge data set was really important. Decisions on, there were a lot of sort of smaller decisions that I think impacted how good the music ended up being. But I think that like eventually we're moving towards the direction of like, we should just have model or architectures that can just learn, and algorithms that can learn. Okay.
And I'd also love to know more about the dataset collection, because one thing, like I really love the EDL piece on the website, but like even when I'm doing this podcast, I'm like sort of cautious about the copyright issues and also how much efforts went into that. and also about the side of the pipeline and what sort of hardware went into this like final MuseNet model.
Sure. So let's see. So on the data set, there are a couple different things on that side. So one, so originally I wrote to a few different people who had big MIDI collections. So like Bit MIDI just donated to me their collection, which was like 200,000 MIDI files or something like that, which was fantastic. And also Classical Archives did the same. They have like, 20 or 30,000 classical pieces. So that was a great start. And then I sort of did a combination of everything, a little bit of browsing around. If I found like big collections that were just available, then I just like use Beautiful Soup to scrape websites or things like that for collections. There were composers who sent me collections, different things like that. In terms of the copyright, so I'm not a lawyer. This is not, I'm not pretending to give legal advice, but my understanding of the way things are currently is that neural nets are able to train on pieces, even pieces that are copyright pieces, but that we're not able to like sit around and listen to the data set and enjoy it, or like, anything like that, we're not supposed to do. But as long as the model is only using it for training, and then on the other side, we can't be like generating a copy of a piece and then publishing it and pretending that it's a new piece or anything like that. So certainly like you can't, on the like hopefully minuscule probability that the model could generate a copy of something, like you couldn't then publish it and pretend that.
I mean, because I'm thinking in terms of like using this as a creative tool. So for like many vloggers and YouTubers and all sorts of people, like they could maybe just like, once MuseNet is available as a platform, they could just like generate some sort of music and use it directly for whatever their project is.
Yeah, absolutely. I mean, we're sort of opened it up and said, like, we're not making any claims on what the model outputs. Like, we have no copyright claim on it. And then, it's a very much an open legal question. And this is even within the US that I sort of only barely understand what's going on. And so internationally, I have no idea if different countries have different rules about this. But yes, please consult a lawyer. Don't go on my...
But it's definitely an interesting field, like to be able to automate this. And also like curious on your music background. So did you like also compose music for the audience? Like there's a difference between composing music and performing. So
yes, no, absolutely. I have tried composing and I'm really bad at it. I wish I could. Like, it's something that I like always wish I knew how to do. I can.
So that's why you went ahead and created a model to do it for you.
A little bit. Like, I have to admit, it's kind of satisfying that like I always sort of, because I feel like in some ways as a musician, like that's, it's neat to be able to like play someone else's piece. But there's something super satisfying about like, okay, this is my piece. This is something I created that's new and different. And like I do, as I was kind of getting into the project and as the music was starting to get better, I was like, oh, this is like, it's actually sometimes like artistically satisfying that you're like, wow, I've like actually created something that's starting to generate, legitimately interesting, good music.
So what's your take on like the creative AI topic? So are you on the side of automating or having the human in the loop? So you use maybe such a model to like give cues that I want a beat that's melodic and uplifting, and then you can like build your music on top of that once you have the bass beat.
I mean, I'm certainly most interested in pieces that are kind of partly reflecting humans. So like, to me, what's really exciting about MuseNet is the fact that, like, say I would like to be able to compose, but I can't compose, and this is like, but I can sort of like that's why I did the sort of co-composer mode that we have up on the blog, where the model gives you like a couple different ideas of how to go, and you pick one, and then it'll generate more, and then you pick that, and you can kind of go along this way. To me, that's a lot more fun and interesting than, press a button and then comes the whole piece. Although I can also imagine it being fun to say, like, today I want a piece I want to go running, and I want a piece that'll, make me want to run faster at this moment or something. Like, I can imagine that being fun, or like, say someone's getting married and they want to have like the perfect, like, this is our love song, and you can imagine like, not MuseNet, but like MuseNet 10.0 or something like that, like generating the perfect piece for someone. But I think all of these still have like that they're reflecting like the emotions of a person, or they're still reflecting some sort of human creativity.
The challenge there is like music, it's such a subjective thing. Like I don't have songs that match up with my friends' playlist most of the time. So
yeah.
also,
it's true, but in the way that like we might make a playlist for someone now to be like, oh, this is the kind of things I like. Now you can just be like, this is the song that is exactly what I like.
Yeah. So do you think like this will also push composers to be like more creative, because you can also already like you can put some cues in and generate music, so that'll give them more ideas, maybe allow, like as we say, like AI creates humans to be more pushes humans to be more creative.
Yeah, I mean, so there's one composer in particular who I've worked with a bit on this, and even to the point where I've trained the model on his music. So then he can write a little bit, and then the model will kind of suggest different, either like different next ways to go, or will kind of react to what he's written. And I think he thinks it's sort of this funny experience where it's often sort of imitating his style, not quite getting his style. It's certainly not as good as like what a human fully, especially when you get to like long-term structure of a piece or something like that. Like the model still has sort of little funny quirks. But I do think that experience of sort of, the model is really good at, here are, 64 different possibilities of what you could do next, in a way that humans sometimes get locked into, like, oh, this is where I'm going. And so it's in terms of creativity, it's neat to be bumped into like all these different kinds of possibilities.
Yep. So do you think like, since you had the background knowledge about music and you were working the transformer model, and I think what you just spoke about, that this model tends to wander off into different directions, that was also visible in the like example shared by OpenAI about their GPT model. So do you think like this helped you debug or maybe understand transformers better? Is like this could be a key to like push the search further for these models, because these are relatively just fresh, cutting edge. Like that's coming.
No, I do find it really interesting that I feel like I can understand a little bit more of what the model is good at and bad at that way. Partly because I think in music, you can look over like, say the course of 1,000 tokens or something like that. That's like, it would be like a lot to read in a text and to try to figure out patterns in written text. Whereas in music, you could hear like, oh, there's like, it was doing really well, and then at this moment it kind of got off on a tangent and it didn't realize, or it messed up the rhythm, or it messed up like, or it like turned on this note here and then forgot to turn it off later. Like I think little mistakes are much more obvious.
Right.
So I think it does sort of give some insight as to what the model is able to do. Also, in terms of like calculating the rhythm can be a pretty complex mathematical problem. So because I'm not ever like telling the model like this is how a musical beat goes, but if you think of like, say you're like dancing along to a piece where there's often like a lot of little things that happen in between the main big beats that we hear. And the model has to figure out like all these little, like say it commits to play this note here, it has to figure out how long to wait to get back to that main big beat. Because if it miscalculates and puts that main beat at the wrong point, then like everybody hears like, oh wait, that was like you just had a misstep there. So I feel like it's a little bit pushing what the model can do in terms of math, what the model can do in terms of copying something from a long time ago. So there are all sorts of like interesting problems that are related to what you might run into in text, but different. So it's kind of fun to explore.
And was you like, since we talk about neural net being a black box model, so your knowledge about music was helpful like in debugging this model, and like maybe were you able to understand what's really going on when you were working with this, like still prototyping it?
A little bit, yeah. And I think in some sense, like what I was saying, but the difference between the kind of music that a LSTM generates versus the music that a transformer generates, like that to me is really interesting. And I think like having those sort of instincts, it kind of gives a little bit more perspective on what models can do and not do. Right. But yeah, certainly there were times where I would, I remember one in particular where I like messed up the mask that the model was, as it was like generating what it was able to look back to and what it was not supposed to be able to look back to. And I like messed that up a little bit. And it was a funny experience because I would listen to the generations and I was like, okay, well, they're not bad enough that I've like totally messed up the model. So I know it can't be. So it did sort of point me.
It sounds just a little off.
Yeah, like it was really interesting to be like, oh, I could kind of like figure out what was wrong with the model based on like the kind of guesses it was making and the way it was messing up the pieces. So that was kind of fun. I was like, okay, I'm actually legitimately debugging by listening to prompts right now.
That's super interesting. I think this is one of the unique fields where that's really possible in a true manner.
Yeah, no, that's actually one of the things I really love about deep learning in general is that, you have these tools and then, you could kind of spin and apply it to a really different field and there's a lot of carryover.
I think that's again where, like we just talked about, the human in the loop concept comes into play. So that's where the human creativity or like the human assistance also plays a role.
Yeah, absolutely.
I want to talk about the framework and hardware. So how much of hardware resources went into training like the final piece that's available online?
Yeah, okay.
Clara was based on PyTorch and fast.ai. So does MuseNet also follow the same approach? And maybe to like just get a hint of, are you on the PyTorch side of things or TensorFlow? Which framework do you like more?
Oh, where I am. Right now I've been jumping back and forth between the two. There's a good hedge tree, but
Okay.
So one of the things that that the transformer architecture took advantage of was Scott Gray, who works here at OpenAI, had written these really nice kernels for the GPU. And so there's this block sparse system that he had created, which just made certain of the transformer operation or the TensorFlow operations really fast and really efficient. And it meant that I could just have a deeper model and something that just wouldn't have been possible any other way. Now, I personally like working in PyTorch, although I mean, it kind of seems, I feel like I don't want to commit now.
Right.
But more recently, I've been kind of returning back to PyTorch and trying to explore some of the same stuff there. But yeah, that was a big part of how I ended up in TensorFlow, because for this, the size of the model really did matter, and I did feel like I was just trying to like squeeze as much as possible out of this.
So I'm trying to think like how much of like this research can be pushed further. Like if I'm trying to replicate this on a single machine, and do you think like any areas that anyone else could like push the model further, improve it in any like loops maybe?
Yeah, that's a good question. I mean, certainly I do feel that the way that you go from the music to the encoding to the tokens matters a lot. And so finding like good systems for that would matter. One of the things that still sort of fundamentally bothers me is the way that we sort of generate by just predicting the very next node, and then based on that you generate the very next node, and it's always this like just looking one ahead kind of thing. Whereas I feel like, as musicians or even as we're talking, like we're never ever thinking like, oh, what's the very next word I'm going to say, and then the next word. We're always thinking in like higher concepts than that. And so I think that like capturing that would make a big difference. But yeah, also in terms of the like how humans can guide what the music's like, I think it'd be fun to be able to say, like to try to push a model to do more like what does the sad music sound like or things like that. I think, but yeah, you're right. I do feel like more and more it's tough to do some of this without having like it is a luxury to have a lot of compute, and that I can just have an idea and try it out, and I do understand that it's a luxury at this point.
But because like in my experience, I just have one single GPU on, like I have two GPUs, this laptop and a rig, a deep learning box. So transformer models are sort of tricky because I cannot play during the evening if I put anything to train for maybe 3-4 evenings in a row. So I think it's still in the development phase for everyone.
Yeah, no, it's true. I think that is a hard problem. Yeah, I mean, I hope maybe we'll be seeing more like partnership. I love the idea of like, if we can sort of bubble up ideas and then, like partnerships where people can use some of this compute that we have, or but this is beyond what I have sort of expertise or power to
Yeah.
to degree. But I think there's a real trade-off, because I have had the experience where, you can push on all these little design details,
Mhm.
and then you just step back and you just train like a deeper model with more data, and you're like, oh, why did I just spend all this time fine tuning it? Because like it just learned, if you just scale it up, and I think everyone is sort of hitting this, like, should we just push scaling for a while and see where that takes us?
Yeah.
But presumably at some point we're going to hit a, like, okay, there are other things that we've missed, and we do actually still need people to be like finding these little tricks.
Yeah.
But yeah, I think that is just a tough problem, and it's something we struggle at here at OpenAI, and also just more broadly. I think everyone's wondering about this.
I think one thing also like that might help as like we improve upon language models. So for example, as we transition from LSTMs being most famous to transformers getting the like fame, that's how I think MuseNet even progress. So maybe the next big model might also like be a stepping stone here.
Yeah, no, for sure. They're probably, I assume they're still just like basic,
Whatever
obvious
it is,
things
like,
that we
I
haven't
have
figured
no
out.
expertise.
Yeah.
Whatsoever.
No, I think everyone always laughs at, like, sometimes, an idea comes out and you're like, oh, that was so simple and it was like so beautiful, and how did we not think of that sooner? And so I think like the field is young enough that it's still wide open for those kind of things.
Okay, so now I want to like sort of shift gears and also talk about your current role. So could you tell us like what project are you working on now? Is it still MuseNet or any other project? And what does a day in the life of a technical member at OpenAI look like?
Sure. Yeah, I mean, so let's see. So I'm sorry, I'm hesitating because like a lot of what we do is, sort of research where we're testing out like different ideas, and a lot of that stays internal until we have a sense of like, okay, this is what's going to work, or this is not what's going to work. So right now I like personally, I'm still interested in music generation at this point. Trying to, I feel like there are like several different directions that are kind of exciting next steps. Like I do feel like there's more to do on the MIDI side of things. Like we haven't even scratched the surface on like a lot of MIDI files also include lyrics. They include, maybe different ways of kind of getting better at long-term structure, getting better at kind of being able to let the human decide what the piece should be doing. But then also I think it's fun to think about what's possible on the raw audio side of it. And so basically, would it be possible to generate long-term stuff but with audio instead? But a lot of it is, it's kind of the fun thing about being here, but you just sort of, you can have an idea and push it for a while, and like fingers crossed, hopefully something comes through that that'll be good. But it's tough though, because
nothing works until it doesn't in deep learning.
It's not like other. I feel like a lot of other like programs or projects, you sort of like, you work for a month and you're like, okay, look, I've done something. Like I'm like a month better off than I was. Then, whereas this, sometimes it just feels like you try a lot of things and nothing works and nothing works and nothing works. And then like suddenly there's a jump and you're like, okay, like it was worth it, I guess, to push through all that time, because I wouldn't have gotten that jump otherwise. But it's a lot harder to be like, I literally could have gone on vacation for the month and like I would have. But I guess it's just it is that sort of like, you have to try a lot of experiments and find what doesn't work. Also,
how do you draw that line? So like maybe like you want to explore further or like put that experiment to an end, because like when you started this, I think Magenta from TensorFlow was there, but not many people were talking about music and deep learning. So even then, like it was perceivably an impossible problem. So when you're working on an experiment and it doesn't work, so where do you draw that line when doing an experiment?
It's a tough question. Like sometimes I think, there's probably a certain stubbornness of just being like, I'm just going to keep pushing because I like have this instinct that something should work. I'm a big fan of like trying to do something that's like simple and dumb, but like maybe at least gets us signs of life of sort of like, maybe there's something here.
So a basic a small MVP model of sorts.
Yeah, just trying to sort of think like, okay, what is like the simplest version of this, so that like, you know, maybe
As a
there's
proof
some
of
way of just like, yeah, exactly, right. And that sort of gives you like, if that works, then you're like, okay, maybe there's something here, like now I'll like add on to it a little bit, and kind of push it that way. That tends to be my approach. Yeah, because otherwise there is this like, you're just wandering around, and like, how do you get any signs of like
yeah.
like our like reinforcement agents who are just like wandering around? Like, you need to give them rewards every once in a while so they know they're like on the right trail.
And like as you worked at OpenAI, and OpenAI of course has like the best people from quote unquote the traditional background in research. So do you think like that has affected in any way how you do your experiments, or any takeaways that you had from that?
Yeah, I mean, I definitely feel like I still have a ton to learn on this side. And it's maybe one of the things I'm like most trying to get better at this point. I think originally I was just in this mode of like, I sort of have like a bunch of different experiments going on, and I was kind of feeling my way through like, this seems like this is doing a little bit better, and I would follow that for a while. But I was not really very good at having a sort of structure of like, okay, I'm going to run these experiments, I'm going to graph it this way, I'm going to like really be clear about like, I made this one change and this got better. And the more I learn from other people here, the more I'm getting better at like, okay, like kind of make sure you have like a clean, it's worth it to take the time to build like a nice clean setup, to have something where you can like look back a couple months ago and be like, this experiment went this way or that way. And it's something that like, I feel like I'm really bad at. Like people sort of push on me, you know, like, is it necessary to have a PhD, all this sort of thing. And I'm like, you know, maybe you can learn this stuff. And I'm trying to learn this stuff on my own. But I do have a lot of respect for like, I think these are the kind of things you learn when you've gone through this rigorous, like, this is how you do experiments well. This is, you know, how you read a paper and pull the most important things out. And like, these are the kind of things I feel like I'm trying to learn from the people around me now.
Right. So like really doing research as a scientist, so having that lab journal of sorts and documenting every step of the way, even like personally, when I'm like, for example, doing a Kaggle competition and things don't work out, I'll just delete every file that comes in front of me, and not doing that, and instead keeping a note of what didn't work out. I think that's what I'm taking away.
Yeah, no, I it's something I struggle with, and I'm trying to get better at it. But yeah, really keeping like clear, like knowing like, oh, this is the change I made, so that when I've broken everything, I can like, you know, figure out how to get back to stuff. And it's just, you know, it's probably obvious things, but things I still manage to do badly. So I do feel like I'm still figuring it out as I go. But
Also
that is very helpful to learn from everyone around me here.
I'm also curious, how does a like research pipeline for you look like? So how do you get an idea of running an experiment, and how do you like ask the questions when you find an idea? So when you start like maybe experimenting on a new sort of transformer comes out, let's say I'm just trying to think for example, and you want to try that out. So how does that pipeline look for you?
Yeah, I think it sort of depends. Like I'm looking like right outside here, there are like 3 people huddled around a whiteboard, and I'm sure like they're doing this sort of thing where like you have an idea and then you like try to hash out like what exactly it is, and you do like, I feel like I do this all the time too, where I you know, you just you know, have this sort of early thought of like, I feel like something should work, but it's not totally clear, and so you try to like, I'm constantly just drawing pictures of like what I think should be happening, what I think the model needs to, I try to think a lot about like, okay, what is the model, like what sort of information is the model seeing? What does it have to learn? Or like is it realistic that it's able to like pull this information from that input? And so sort of trying to visualize it first, or kind of have that instinct for it first. But then it's a lot of just like, once I have a clearer picture of that, then I do try to, you know, either it's usually just a matter of like coding up that idea, trying to compare it to the previous version. A lot of looking at graphs and trying to see if see if there is a clear difference of things. I guess the usual sort of steps at that point. But yeah, I do feel like I try to spend a good amount of time of just brainstorming and kind of bouncing ideas off other people as well, because oftentimes that's where someone's like, oh, there was a paper about such a like, go look at that.
Okay. Also, what would be your best advice? Like, if I may, you're not from a traditional research background. So
Yeah.
for someone who's like taking the MOOC education path, online education path, and trying to get a break into research, so
Mhm.
what would be your best advice or things to look out for them?
Yeah. See, so I feel like there's sort of multiple parts to that. So for me, when I first took I took Andrew Ng's deep learning sequence first, and
Yeah.
I think at that point, like I felt like I was getting the concepts, but I didn't feel very comfortable with like coding anything up on my own at that
Yeah.
point. Like I still felt like everything was really overwhelming, and I think sometimes it's helpful just to like go into something being like, okay, this is not like, I'm not going to feel fluent in this in a month or something like that. It's like, I will feel much better in a month than I do now, but it's like, you know, it's really normal to just have everything feel kind of too overwhelming for a while.
There was this tweet that mentioned like coding programming is like going to the gym. Everyone's better than you, and you keep doing it, and eventually you'll get better without realizing.
Yeah. It's funny. I actually like just a couple of days ago was thinking like maybe one of the best things about playing piano is that you constantly, like, you're trained to constantly have this feeling of like you open up a new piece and you're back to scratch. Like you're like, yes, you're better than if you had never played piano again. But it's like, honestly, like you look at a piece and you're like, oh my gosh, this thing is like, this is a huge piece. I'm never going to learn this in time for the concert. It's this, you know, and you just like constantly have this feeling of like, how am I ever going to have this whole concept fit in my head kind of thing. And then you just learn like, okay, well, like today I just need to start with this first page and I'm only just going to learn this opening and it's going to be slow and it's going to be horrible. And then the next day, you know, and it's just, you kind of get used to like, okay, it's just going to be bad for a while. And you sort of have that discipline of being like, it's okay. Like it's not like it means that I'm a bad pianist or a bad programmer or whatever. Like, it just means that like, this is literally something that I've never done before. And there's no reason I should know it. But yeah, I think in some ways, one of the nicest things being here at OpenAI is like, if you ask anybody about an architecture or something that they haven't done yet, they're also like, I don't know, like this is my
even,
and you realize
the
like,
best researchers
exactly, that's what I mean. Like, so, and yes, like there's, you know, they're smart and they will learn and they'll figure it out kind of thing. But it's like really reassuring to be like, okay, like literally nobody just magically knows this stuff. It's like, you go through and you learn it, kind of thing.
Could you confirm or deny, like once you're a researcher, can you just read a paper and think of like magically code appears in your head? Does that happen, or do you still like sometimes struggle with those aspects?
I don't know. I sit next to Alec Radford and I'm pretty sure that is like how his brain works.
Okay. But maybe for you.
For me, no, I mean, I think I've gotten better at that. But yeah, I still feel like it's something that I'm learning and have to work on getting better. Like, I think it's like anything where that's a skill that like the more, so the fellowship program here literally is, here's a paper, now code it up kind of thing. There's like several weeks of that. And I think that that's a good skill to go through or like good thing to practice. Yeah, but I do think in some ways, one of the frustrating things about papers is oftentimes you take an idea that's like a clear, nice idea, but then it has to get sort of presented in a more elaborate feeling way. And so I sometimes feel like reading paper is just trying to like undo and go back to like, what was that kind of like actually core idea?
So like one of the problems that I always struggle with, and I'm active in a couple of communities where many people tend to do is like, they feel like, I feel I'm not good at Python and I want to do like some deep learning project. So what do you think, like, should one spend some time on maybe like doing Python problems, or just like what I do is clone any project and start running it, start tweaking things, and then trying to get a hang of stuff? So how would you
do that? Yeah, I've done both of those. I did, especially preparing for interviews. I spent a while doing, I really like HackerRank. So I like went through all of the like, you know, and especially I felt like, okay, I don't have a computer science background at all. So like I need to learn all this stuff. So I did go through, they have like a cracking the coding interview sequence. And I spent a lot of time going through that. I like binge watch what's his name? Sedgwick's algorithm. His like algorithms class is on YouTube. So I just
We'll
like
have that link
went
in
through
the
that whole series. Yeah. So like stuff like that I did go through.
But like I have a CS degree, for example, and many of my
Yeah.
friends
So
do, but
okay.
we
So
still struggle with it all the time. So for
yeah.
such people,
Okay. So I did that because I didn't have your background kind of thing. But yeah, I kind of go back and forth between both. Like I think there's a lot to
okay,
be said for like being able to take existing code and tweak it. But I think it's like it's very liberating to be like, okay, I can start from a totally blank screen and like
yeah,
and make a model that works. Like, and I think just kind of like I remember that like it just like felt a little overwhelming and impossible at first. But like it's
yeah,
no. So I do think practicing even with like some simple models and just be like, okay, that's actually in some ways like why I started out with the music thing in the first place was I was like, okay, let me just, not only depend on somebody else's code, but let me practice just writing something up from scratch. Because I do think like, yeah, once you sort of cross that point, then the possible, like the number of things you can try out just opens up a lot,
okay.
which is nice.
Got it. And I had also reached out to you like when I was preparing for the Google AI residency, and I
Yeah.
didn't like, I was sort of scared of the NDA, so I didn't tell you
Yeah.
anything, but I was sort of secretive about it. But yet you like shared many advices that were like pretty helpful to me. And then I realized that all of these programs sort of follow similar structure. So could you like
Mhm.
maybe for the audience, like what tell us what are your best go-to resources for a whiteboard or a coding interview and for the research interview? So that most of the interviews follow these format, I think.
Yeah. So for the coding interviews, like that was where I did just practice a lot on HackerRank, and I felt like that was the most useful for me. Like I felt like by the time I got to like the medium level questions being
Yeah.
easy, then I felt like, okay, now I'm ready. And that's been my experience so far. I've done a few different interviews and like everything has been at that level.
Yeah.
In terms of the deep learning ones though, that I feel like is tougher because I think it's still pretty wide
Subjective.
open. Like so you sort of never quite know. Like the OpenAI questions were a little bit all over the place. And the nice thing about it is I felt like they were always kind of fun and interesting problems. So I remember
Yeah.
going through the interviews being like, well, if nothing else, this was like entertaining to try to figure out how to solve this problem because like it was interesting. But I remember I would like cram the whole week trying to prepare for the interview, and then it was like never anything close to what I had studied. So,
Okay. That
I,
was similar for my experience also.
yeah,
So for the Google AI residency.
yeah,
But
it's
I
just
think I
yeah,
think your advice about the medium questions was definitely very helpful. So I did like try a bunch of medium and hard questions, and
yeah,
like that. Unfortunately, I didn't get selected, but that was definitely helpful. So I did realize that.
yeah, yeah. I think just because at the end of the day, like I don't feel like the whiteboarding coding stuff, like it's not really the kind of stuff I use on a day-to-day basis
Yeah.
anyways. But I do feel like, okay, you might as well, like it's just like a specific number of things you have to learn there, and you might as well just feel fluent so that you don't get, caught up or nervous or something like that on. So.
Got it. Also, like in your interview on like the blog interview, I'll have that linked off. And also in
Yeah.
your blog post, Learning Deep Learning, you mentioned that you echoed Jeremy Howard's advice about doing one project and really like pushing it to be the best format. What advice do you have for the people who don't have that idea yet? So you had your like music background and you had your idea, but for someone who's
Yeah.
still exploring and still looking for that idea.
Yeah. That's a good question. Yeah. I mean, to a certain extent, I think it is okay just to explore for a while. I guess for me, like what my ideas have always kind of come from my like outside day-to-day life. It'll be like I'm watching the way my kids are learning, and I try to like think of like how could I do that better? Like how could I build something that would help them? Or it was like while I was playing piano, the page turning thing. So things that maybe just try to think about things you run into in day-to-day life. Like I think the advantage we all have coming into the like deep learning or AI world is that we have our own life experiences that are just like probably wildly different from most people in the field. And I think, that aspect of like, how could I apply this to some topic that I know about that that somebody else won't know about at all. That to me is where it's sort of really interesting.
Right.
But yeah, I don't know. That's a good question. I guess also just talking to a lot of people, hearing for me, often ideas come from, sort of, I have like a fledgling thought, but then it's only when I'm like talking back and forth with other people, then I think like, oh wait, actually this was totally the wrong thing to do, but the other, something else is much better.
I think it's also brought up in the fast.ai course that many times we try to think of like mathematical equations being researched, but many papers do only speak of where did the intuition come from, and that's from real life. So really just like those shower thoughts, and we had Jason Antic on the show also. He's created Deoldify. So for him also it was really the shower thought, as you mentioned.
Yeah. I just went swimming yesterday, and it was like swimming in the pool where I was like, this is the best place for ideas because you can't get distracted. You can't like pull out your phone or like listen to the radio, something else. It's just like those stretches of time where it's just like you and your brain. I feel like that's really important.
So I also want to ask you, like, of course, you must have worked really hard. If I may, you mostly MOOC taught before you joined OpenAI, but you're also one of the smartest person that I have the privilege of knowing. But how did you structure your approach when doing a online course? Because I tend to get demotivated and sometimes also wander off in all tangential pathways. So what advice do you have for someone just doing MOOCs for
It's
education?
A good question. It is tricky. One of the things I've noticed is that like certain MOOCs I like start and I just get obsessed with and I can like power through it really fast. And then other ones I start and I just like, and I like, it just feels like it's a struggle. And I guess I've learned to be okay with like, okay, that one's just not for me. And like the nice thing about having just this enormous online resource is that you can afford to do that. Like in a way that if you're at university or something like that, you can't be like, well, I don't like this physics professor, I'm just going to walk, like there's no option. But online, actually, I loved my physics professor, so I shouldn't say but it is really nice that you can find, like, yes, this one course might be what everybody loves, but if it's not the right fit for you, then that's okay, and find another one. But in terms of structuring it, I mean, I do tend to be very deadline oriented. So I guess like as much as I can try to set either, sometimes I have to like set myself an artificial outside deadline. Like now with research, I'll sort of commit to like, okay, I'm going to present at the next meeting or something like that. So like no matter what, I have to have something together to show for that. And so, sometimes it's a matter of just like having a single other person that you're kind of, maybe you agree to like every Thursday, you're going to get together and talk about, the MOOC that you just did this past week or something like that sort of thing. I think can be helpful. To me, I think it's like a combination of that, like either just like look around until you find the course that like really speaks to you and that you can just sort of fly through, or find ways that, and I think everyone's different, but try to understand like your own personality and how you're motivated.
I had Edward Harris, the CEO of Sharpest Minds, on the show. So he also brought up the same point that being accountable to maybe a mentor, that's what they do at Sharpest Minds. Or maybe just using Twitter as a platform, that just tweeting it out, hey, I'll be completing Fast AI by the end of 3 weeks.
Actually,
and that sort of sets a deadline for you.
In the Scholars program at OpenAI, you have to write a blog every week, and that is really good motivation to have something done that week. So I think if you commit, some people write out a newsletter or something where you start to realize like, okay, will notice if I can't just blog about nothing. I have to have tried to get something done. So that can be helpful.
That's been my experience. At the beginning of the year, I tweeted out that my resolution is to put out one blog post every week. So it's definitely challenging, but that's what like many of my annoying cousins, if you're listening to this, thanks for that. But they bringing it up that you didn't put out anything, and that's also like in a way a motivator for me.
Totally. Yeah, absolutely.
Also, if you could maybe like list out your favorite MOOCs. So you must have explored a bunch. So your favorite online courses for deep learning or machine learning.
Sure. So my two sort of biggest go-to ones are the fast AI sequence, and then also I really like the Andrew Ng deep learning sequence. So I actually did it in the reverse order. I did the Andrew Ng's courses first. I felt like those kind of gave me a great, like I love his lectures. They're in these nice bite-sized, like 5 to 7 minute kind of videos that you can just kind of fly through. So I did those first, and then I felt like when I did fast AI, that was more about getting more confident actually coding things up myself. Jeremy's always on this, like, just go ahead and dive in and build it, and don't just click through. Make sure you can actually do some of this stuff on your own. And so that to me was super helpful. So those are my two biggest ones. Yeah, I mean, oftentimes I'll sort of, if there's a specific paper, I hate reading papers, to be honest. So like oftentimes I'll like try to look for blogs that'll talk through a paper. But I don't have any one sort of go-to thing for that.
I agree on that, because like people feel that a computer science background person might be comfortable with it, but I don't think that helps in any way in reading any sort of paper. And I follow Jeremy's advice again, just skipping the equations, and I'd sometimes read the subtitle of the equations to maybe get an understanding of, okay, this is what's going on here. But that eases up things for me. Like I can just skip the equations, and that really cuts down the time for me of reading the paper.
Yeah, I think the nice thing about like the more papers you read, the more you're like, oh wait, this is the same equation that just pops up like everywhere. People just like give fancier names to everything, or like as soon as you start realizing like, okay, like there really are like a set number of things that will show up everywhere, then that makes it easier also. But yes,
one last question would be, what best advice do you have for people who aspire to work as researchers in the field and like are in the phase of following an online course?
Yeah, I think the biggest thing for me is just developing this mindset of questioning everything. So I think we're sort of, you get used to in school, like you learn like this is how something's done, and then this is like you're constantly being taught like this is how you do math, this is how you do physics or whatever. But instead flipping that around and being like, so someone gives you, this is how this architecture is, and you're like, but why? Like why does this have to be that? Did you try this? Did you like what happens if you do something else? Like just kind of having that as your default mindset is really powerful, because especially in this new field where a lot of these decisions were totally arbitrary, and it's just because like we did it because it worked or whatever. And so sort of
it just works.
Yeah, exactly. Basically taking the extra time to sort of like, well, look at what your model has learned. Like, has it, try to visualize it. Has it done anything sensible? Kind of always like your default should be like, maybe there's been some silly mistake and we're doing this all wrong. Like try to ask questions about everything.
Okay. One also, like this is sort of a personal question for me. I realized that you've also had some background in Unity. So have you played with OpenAI 5? And could you maybe confirm or deny, because this is very personal to me, does OpenAI plan of doing anything to Counter-Strike and PUBG the game? Because I don't want to be defeated by a bot there.
Oh, wait, sorry, can you say that again? So this is about the Dota,
yeah, exactly. So these two are also some games that quite a few of my college friends and I play.
Oh, I see. So basically, like, what's going on next with the Dota team, or with the? You know what? I don't know. I'm probably not the best person to ask on this. I know that they've been having tons of meetings, but I don't have the inside scoop on what's going on with that. So yes, and I have tried playing Dota one time, and I was really bad at it. So.
But please steer them away from Counter-Strike and PUBG if you hear that. That's from many college students.
All right, I will spread the word.
Thanks so much. This was really amazing. And before we end the call, what would be the best platforms to follow your work and follow you?
That's a good question. Actually, I should put it out here now, because my resolution at talking how do you get stuff done? My resolution is to go back to actually doing some more blogs on my own page. I kind of did them as long as I did the scholars program and then fell off. So this will be, I'll commit here to saying I will, I'll go ahead and get that blog going again. But otherwise, yeah, you can visit MuseNet on the OpenAI blog. I think at this point, if you just look up MuseNet and OpenAI, it'll go right there.
All right. I'll also have your Twitter and any other profile that you want to be linked in.
Yes. Yeah. Twitter. I try to be more active on Twitter, but I'm basically a quiet person and I hate sort of being big on the internet.
Okay.
But I'm trying to force myself to do it. So I will, Twitter and my website are probably the places to go.
Got it. All right. Thanks so much, Christine, again for joining me and giving us these amazing advices.
Okay. Thank you so much. Yeah.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.